Hi, we're going to go ahead and do problem 2. And just be patient with me on this video because we have to talk about outliers. And I'm going to show you the easiest way to do it. There's a little bit of work on it, but once you get it done, it actually it'll go easier. If you put it in the calculator and try to solve for it, sometimes the graphing function just is not good and it will give you errors. So I'm going to show you the way to do the mathematical part of it, and it might be easier. So here we go. Okay, so the cost of a leading laundry detergent in different sizes is given. So you have sizes 16, 32, 64, and 200 ounce. The cost for the 16 ounce is $3.19, for the 32 ounce is $3.99, for the 64 ounce is $4.89, and for the 200 is $9.79. Your costs are going to be different. I've looked at like 6 different problems of this before I made this video, and they were all different. So know that my numbers are going to be different than yours, so you just need to look at it. Okay, so the first thing you want to do is go down here and look at the pictures. So I know it says that the size is the independent variable, which means it's the x variable, is the x-axis. The cost is the dependent, which is the y-axis. So let's go ahead and look. And it looks like it has all the sizes on the X. But now we need to look at the cost. So we know the bottom two, the cost only go to $8, so that will not be correct because our cost goes almost up to $10. So don't even look at the bottom two. So let's look at here. So it's saying for 16 ounce, it's $3.19, which that is really close. Then for the 32 ounce, it's $3.99, which is basically 4. 64 is basically 5, and then 2,000 is $9.79. So that is great. So we're going to pick this one. So, okay. Then we keep going down. And does it appear from the inspection the relationship between the variables? So let's look at this. It almost seems like there could be a line made from this. They actually go, if you look at it, they're kind of spaced along a line. So what we can say is, yes, it appears that cost increases with size. And you can even look at that when you look at the actual data, okay? All right, so let's keep going down. So here, calculate the least squared line. All right, so here we go. We're going to put our stuff into our calculator. So let me bring up my calculator. All right, oops, there it is. And I'm going to bring it over here. Come on, calculator. Let's see if it'll let me move it now. Okay. For some reason, it's not moving, so we'll just put it here. So we're going to do stat, enter, and then L1 again is going to be the sizes because it's the X. So it's 16, 32, 64, 200. Oops. Okay. And then over here we have $3.19, $3.99. Oops, not $6.99. $3.99. Okay. Oops. Okay, and then we have $4.89. And then we have $9.79, okay? So I put those in. All right, so then I go to Stat, go over to Calc, and I'm going to not go to LinReg, I'm going to go to the bottom one. You can use LinReg if you want. This one actually has the format that they're looking for. Oh, and I don't have my R or my R square, so that's really important. So I need to do seconds, 0, go down, and I need to go to Diagnostic On, because if I don't have everything I need, I can't finish this problem. So I go to Diagnostic On. Hold on. Hit Enter, and then hit Enter. Okay, and then if I go to Stat again, go over to Calc, go down to 8, hit Enter, boom, it gives me everything. Okay, so what it says here is calculate the line of least squared. So it wants it is y equals ax plus b. Okay, so my A, and they want it in 3 decimal places, my A is 2.705. I'm going to round up because that 4 is right next to a 6. And then for B, it wants 3 decimal places, so that's going to be 0.35. So I'm going to go here. So A, I'm going to be at 2.705, and here I'm going to put 0.035. Okay, I got that from the calculator. All right, what is the correlation coefficient? So that's just the R. And remember, that's why I went back and I did that diagnostic on so I could get my R. So it wants 4 decimal places, so it's 0.9993. So I'm going to put that here, 0.9993. Is it significant? Yes. The closer your R is to +1 or -1, that means it's a strong linear relationship. The closer it is to 0, it gets weaker. So if it's a 0, if your R is a 0, that means there is no correlation between the two. So think of 0 to 1, with 0 being the weakest and 1 being the strongest. It's kind of a sliding scale, with 0.5 being like a medium relationship. And it goes the reverse way with -1 to 0. -1 is a negative strong linear relationship, where 0 is no relationship. Okay, so I'm going to keep going down. Oops. So what would it be if my laundry detergent was sold in 20 ounces? Okay, so I need to bring this back up. So I'm going to go, turn it back on. So I'm going to do clear. So then what I'm going to do is I'm going to put that 2.705. Now, where did I get that again? Remember, it's here. It's this equation that I'm just doing again, okay? Plus, and I'm going to do parentheses, 0.035 times 20. And what do I get? I get 3.405, and I round that 0 to 1, so it's 3.41. So that would be the price. Okay, now it wants me to do it for 70 ounces. I do the exact same way, except this time instead of 20, I put 70. Plus 0.035 times 70 equals 5.16. Okay, so 5.16. Okay, so here we go. Does it appear that there's a line of best fit? Well, yeah, we're seeing that because if you look up here, as the sizes increase 20, so let's look at that 20 ounce, yeah, it falls between what we get for the 16 and the 32. And then how about the 70? The 70 is above that 489. So we're seeing that it's increasing at a really nice positive trend. So yes, the data does fit an almost perfect positive linear trend. All right. Are there any outliers? Okay, this is where we have to kind of be careful, and this is where I've got to show you how to do this in Excel. All right, so here's my Excel file, okay, and I have my X values and my Y values. All right, the first thing I need to do is I need to go back here and I need to bring this up. Let me do this. Okay. Sorry about this. I'm trying to move it and it won't let me move it. Move. Okay. All right, there it goes. Yay, it finally moved. All right, so what I need to do, all right, for over here, I need to do 2.705 plus 0.035 times 16, and then I hit enter. Okay, so what did I get? For this one, I got 3.265. Okay, I'm just going to put, you could probably go ahead and round up this to 7. Let's just do that, okay? So what I'm doing is I'm taking the actual values that I had. Oh, sorry about that. I'm taking the actual values that I had, and I'm plugging them into the calculator with the linear regression function that I had. Okay, so I'm going to do it again, 2.705 plus 0.035 times 32, and I hit enter. So this is going to be 383. Okay, and I go here. I'm going to do the next one. So I'm going to do 2.705 plus 0.035 times 64. And I get I'm going to put 4.95. And then for this one, our last one, I'm going to do the 200. So it's going to be 2.705 plus 0.035 times 200. Okay, so what did I just do? All I did is I took my actual X values and I plugged them into our line that we got off the calculator. So this one is going to be 9.71. All right, look how close my Y values are to these actual Y hat values, which is really, all I did is I plugged my X into my line of best fit, and that's what I got. All right, to get this, all I'm going to do is I'm going to take the original value, 319 minus 327, and get what I have for that. But the way I'm going to do it is this. I'm going to do equals. I'm going to do this minus this and hit enter. Okay? It's okay if you have negative numbers. All right? So let me show you again. I'm going to do equals. I'm going to do this minus this gives me that. Okay? And I'm just going to do that for each one of these. So I'm doing the actual Y value minus the Y value when I plug in X, all right? And one more time, minus this, enter. Okay, so I have my actual values, and these are called the residuals. All right, so the next thing I need to do is I need to go back to my calculator, okay? And I need to go stat, and I need to go over to, okay, remember, let me go back. I have my data in here, okay? So then I need to go over to stat, go over to test, and go down to linreg for a regression right here. I'm sorry, linreg t-test. And I need to hit enter, and I just need to go in and hit everything down to calculate. And then I need to go down here, and I need to get this S value. So I have S equals 0.135. Let's go ahead and just take 3 decimal places. So I'm going to put here S equals 0.135. What is this? This is the standard deviation for this whole linear regression that you're running, okay? So now what we need to do is I need to see, so this, remember, this is your standard deviations. I need to see an outlier will be, it's going to be 2 standard deviations, and I'm just doing this above, and an outlier can be 2 standard deviations. I'm going to just do this below, okay? Oops. So when I'm doing this, so what I'm going to do is 2 times 0.135 gives me, I'm going to do that 2 times 0.135, and I get 0.27, 0.27. Okay, remember that 135 is coming from here, okay? I just rounded up. It's that S value. That means your standard deviation, okay? And then here, you're going to do negative 2 times 0.135 equals, so negative times 0.135 equals negative 0.27. So basically you're going to have anything, oops, I don't know why it's doing that. I'm just going to put this negative 0.27. I hope it didn't change it. Okay, good. Okay. So what it's doing then is you need to see is if there's a residual above, so let's write this again, above 0.27 or below negative 0.27. Okay. If they meet any kind of this criteria, that means it's an outlier. So look, we don't have anything below negative 0.27 and we don't have anything above 0.27. So we can go back here and say, no, we don't have any outliers. If something falls outside that range, that means you have an outlier, okay? So the next question wants to know, is there a least squared line valid for predicting a 300-ounce size of laundry detergent? Okay, remember when we looked at all this, we really didn't have anything that went that big, correct? We only had stuff that went to 200. And that's important because they're trying to trick you because they want to know, all right, what is going on? Can I use, because I've predicted all this, the only values that you can predict for is from 16, 32, 64, and 200 ounces. That's it. You cannot do anything else. So what you're going to say, because you just say the least squared is not valid for predicting the cost of a 300-ounce container because 300 ounces is beyond the range of the X values. That's all you need to say. All right. And so for part J, what is the slope? Okay, so let's go back to here and turn it on. And I'm going to go back to stat. And I'm going to go back to here. I'm going to go down to 8. And hit enter. All right. Oops. And hit enter again. My slope is for this one is B, correct? So I'm just going to put 0.035. That's my slope. And we saw that before we used it, okay? So then, all right. What are we going to say here? This is kind of a sliding thing that's kind of, it's talking about the slope, okay? As the number of liquid laundry detergent increases by 1 unit, the laundry detergent's cost increases by 0.035 dollars, okay? That's what it's talking about. So let's talk about this. It's saying as your X increases by 1, ignore what I just said. Let's go back up and make sure we're doing this right. No, and I did tell you right. Okay, let's go back here. We picked this one to be our cost, okay? Let's look at this graph again. We're saying as we increase for the size of the laundry detergent, the cost will increase. And it increases by $0.035, or think of it in terms of that way in dollars. We're not going to use cents because we don't want to confuse you. But what was slope? Go back to algebra. It is the change in y over the change in x. Slope is the change. So this is what that is. So what we're saying, as your x increases by 1, your y increases by the slope. And that's how you do problem 2. I am so sorry this was a long video, but I hope it helped, and let me know if you have questions.